Number 5 asks us to derive the analytic equation for a parabola whose focus is 0, 6, and the directrix on the line y equals 2. Okay, so what I first did was I just kind of sketched a little drawing of this over here. Here's our directrix, and here's our focus. Now, I also drew the parabola, just a sketch of it right here. So first thing you want to do is you can label anywhere you want on the parabola the point. You could just call it x, y. So first thing we want to do is write an expression for the distance from this point to the directrix. So if we want to find the distance from this point right here to the directrix, we're just looking for the distance from here to here. So we can just call that y minus 2. Okay, next thing we want to do is we want to write an expression from the distance from the point xy to the focus. So from this point to this point. Now we're going to need to use the distance formula for that. So the distance formula tells us that we can write that point as the square root of x minus the x coordinate of the focus, which is 0 squared, plus y minus the y coordinate of the focus, which is 6 squared. All right, now remember, a parabola is all the points that are an equal distance from the focus and the directrix. So what we're going to do is we're just going to take these two expressions and set them equal to each other. So this is what we have to solve. All right, for right now I'm just going to bring the y minus 2 down. And within the radical, we have x minus 0 squared. Well, x minus 0 is just x. So when you square that, we have x squared. And then plus y minus 6 squared is the same thing as y minus 6 times y minus 6. Okay, so again, let me just bring the y minus 2 down. And under our radical, we have x squared. When you double distribute the y minus 6 to the y minus 6, you wind up with y squared minus 6y minus 6y plus 36. So we can combine our negative 6y and our negative 6y to give us negative 12y. So we'll have basically rewriting the same exact thing we had, except I'm writing minus 12y instead of minus 6y and minus 6y. Okay, so now that we have that, in order to get rid of a radical, since we have a radical on the right-hand side of the equation, if we want to get rid of it, just square both sides of the equation. Because remember, a square and a radical cancel each other out. So on the right, we're left with x squared plus y squared minus 12y plus 36, because that square canceled off the radical. On the left-hand side, when something's squared, it means we have two of them, so I'm going to take the y minus 2 and write it out twice. Now, if I double distribute that, I'll get y squared minus 2y minus 2y plus 4, and I'll bring down the right-hand side of the equation. Okay, so now what we're trying to do is we're trying to solve this equation for y. Since we have a y squared on both sides of the equation, we could just cross those off. If you subtracted them from both sides, they would just cancel off. And then I guess what I'm going to do is I'm going to move all my y's to the left-hand side of the equation. So I'm going to take this negative 12y, and I'm going to add it to both sides of the equation. So now when I combine negative 2y, and negative 12y, oh, I'm sorry, positive 12y, let me change that. That'll wind up giving me 8y, and I'll bring down this plus 4 equals x squared plus 36. All right, we're still trying to get the y by itself, so I'm just going to subtract 4 from both sides, which leaves me with 8y equals x squared plus 32. And to get rid of the 8 in front of the y, just divide both sides by 8. So when we do, those 8's cross off, so I'm left with, I'm just going to kind of come off to the side now, y equals, well, I can either write this x squared over 8 as x squared over 8, or if you want, you could write it as 1/8 x squared. I'm going to leave it as x squared over 8. And then plus, we also have to divide the 32 in the 8. So 32 divided by 8 would be 4. So we're left with y equals x squared over 8 plus 4. Or if you want, you could take that 1 that's in front of the x squared, this 1 right here, and you can bring it out to the front and write it as 1 over 8 x squared plus 4. Number 6 just asks us to perform the indicated operation and express your answer in a plus bi form. Okay, so we'll start with part A. You could start this a number of different ways, but I'm going to just first take the negative I and distribute it into the first parenthesis. So when I do that, I wind up with negative I times I is negative I squared, and negative I times negative 3 is positive 3i. So I'm going to put that in a new parenthesis now, and I'm going to bring down the I minus 3, and I might as well just distribute this negative into this parenthesis while I'm at it, so it would give me negative I plus 3. Okay, so now, since I have a binomial times a binomial, I'm just going to double distribute. So negative I squared times I would be negative I cubed. Negative I squared times negative 3 will be positive 3I squared. 3i times I is positive 3i squared. And then 3i times negative 3 is negative 9i. And I'll just bring down the minus I and the plus 3. Okay, from this point, you never want to leave your answer with exponents on the I. So if we recall, I to the third is equal to negative I. So after I bring down the negative sign, I'm going to replace this I to the third with a negative I. And also, I squared is equal to negative 1. So I'm going to replace the I squareds with negative 1s. Then I'm just going to bring everything else down. So I'll bring down the minus 9i, the minus I, and the plus 3. Okay, so from here, well, a negative times a negative is a positive, so we'll wind up with positive I. And 3 times negative 1 is negative 3. Again, 3 times negative 1 is negative 3. And I guess I'll just bring everything else down again. So minus 9i, minus I, and plus 3. And all you really have to do from here is just combine your like terms. So if we combine the numbers, we have a negative 3, a negative 3, and a positive 3. So I'll just cancel off one of the negatives with the positives, so it leaves us with a negative 3. And then when we combine our i's, we have I minus 9i minus I. I'm just going to cancel the positive and the negative again, so we can bring down the minus 9i. So it leaves us with negative 3 minus 9i. Okay, now part B, all they want us to do is just take it and square it. So if something's squared, it means we have two of them. So I'm going to take the 1 minus 3i and write it twice. This one's actually a little faster. So when we double distribute, 1 times 1 is 1. 1 times negative 3i is negative 3i. Negative 3i times 1 is negative 3i. And negative 3i times negative 3i would be positive 9i squared. Now keep in mind, we know again the I squared is equal to negative 1. So if you replace this with a negative 1, 9 times negative 1 would just be negative 9. So I'm going to bring that down as a negative 9. And let me just bring everything else down. 1 minus 3i, and we already have the minus 9. All right, so again, just combine your like terms. 1 minus 9 is negative 8, and negative 3i, and negative 3i is negative 6i. So in number 7, we just have to rationalize the denominator, which means we want to get the radical out of the denominator of the fraction. So since we have a radical x minus 5, to get rid of the radical in the denominator of the fraction, we multiply by the conjugate of the denominator. Conjugate means just to change the middle sign. So we're going to multiply top and bottom by radical x plus 5. Okay, so I'm going to start with the bottom. When we multiply out the denominators, radical x times radical x is x. Radical x times 5 is 5 radical x. Negative 5 times x is negative 5 radical x. And negative 5 times positive 5 is negative 25. So we were able to eliminate the radicals in the denominator because what happens is the two middle terms, the positive 5 radical x and the negative 5 radical x, cancel off, leaving us with x minus 25 in the denominator. Okay, now in the numerator, you can distribute the 10 to both terms, which leaves you with 10 radical x and then plus 50. So I'm just going to bring that down because it looks like there is absolutely nothing that can simplify. So that is going to be our final answer.